Okay, good afternoon, friends. So today we're learning section 8b, doubling time and half-life. So before we learn on this topic, I want to show you guys a video talking about the world's population. Why do I want to show a video talking about the world's population? Do any guys have any idea? Any opinions? Okay, so because our exercise question is about population, right? So I need to show a topic on this video on this topic. Okay, so let's get ready. So this is a video is called Human Population Through Time. It's 6 minutes and 24 seconds. Okay, so we finished watching this video. Now is the discussion time. So does anybody want to share their observation about the video? What do you notice? Something interesting, something significant? Anybody can share. Welcome. Okay, nobody answer? Okay, Aniandra, thank you. So that's the so-called exponential, right? At the end. Yes, so let me share one of my observation. Do you guys notice that every time when human civilization having a major advancement in agriculture, the population jump significantly, the growth. Every time that when we have an agricultural revolution, from hunting to agriculture, then we have the industrial revolution, right? Do you guys notice this detail? Give me some feedback. Speak out, please. You're very encouraged. Okay, I see Queen said it seems very interesting to see the prediction where the population will be at the 21st hundredth year. Okay, cool. Thank you for sharing. Okay, so does anybody else want to share anything about the population issue before we dive into the calculation? Okay, so let's do some calculation. Today we're learning the section 8b. Okay. First, two important definitions of today's class. They're all related with time. The first is called doubling time. That is the amount of time it takes for the quantity to double. Okay. The keyword is the amount of time for quantity to double. Half time, the amount of time it takes the quantity to reduce its size in half. Okay, so I hope those two concepts are pretty intuitive. Just imagine the population video we just watched. How long does it take for the population to double itself? Okay, so also imagine how much money you have in your bank account. If you're not making any new money, how long does it take to reduce to half of it? Okay, so how do we calculate using those concepts? Okay, assume you know that the doubling time. After time t, an exponentially growing quantity with doubling time t double increases in size by a factor t over capital T double. So look at this part. This part is this, right? So it looks very abstract. Imagine you have 2 years. It takes 1 year for your money to double. 2 years. What does 2 years mean? So the first year you doubled, second year you quadrupled. So the first year double, the second year four times, right? So if you have 2 years and it takes 1 year to double, you are doubling and doubling, which means you have 2 to the 2 over 1, 2 over 1 here. So a factor of 2 to the 2, which is 4. Just putting things in context. So we will be more clear with this idea when we do the exercises below. The new value of the doubling quantity related with the initial value is given by new value equal to the initial value times 2 to this power. It's not, right now it still looks very vague. We will see how this thing works in the below exercise. Okay, does anyone has any question about the definitions or my explanation about the ideas here? So, assume you do not have any question, let's work and problem out. Big town, obviously this big town is not in Montana, has an initial population of 10,000 people and growing at double time every 10 years. What will be the population in town 50 years time? By what factor is the town increasing at this time? I give you one minute to read this question and think about it. As always, try to find all the information you need in the formula, okay? So 1 minute to read it, to think about it. And I will talk about it 1 minute later. Okay, so let's find all the information we need to do the calculation. So look at this formula. What is the initial value? It's 10,000, right? What is the doubling time? 10 years, right? So the doubling time, T double equals to 10. We just pour all the information we need for the calculation. How much time do we need? We want 50 years. So after 50 years, we want to know the population. So the T equal to 50, right? So we find 3 pieces. So the leftover job is doing the calculation. So new value, just copy everything you have. Initial value, 10,000 times 2 to the T over double just 50 over 10, right? T over double. So this is just 5. So 10,000 times 2 to the 5. 2 to the 5 is 32, by the way. So 10,000 times 32 equal to 32 hundredths. That's it. So we have 32. I'm sorry, 30. I think I missed 1 0. 1, 2, 3, 4, 4 zeros. Yeah. 320,000 people in the town. That's it. Does anyone has any question about this one? Now you see the pattern. So every time we read a question, we try to pull out all the information we need for the calculation. And we make sure our calculation is correct. And that's it. Once we're done with doubling time, I also want you guys to have a look at this halving, half time. Half time describes the situation where your population or your value is decreasing. I give you, let's say, 2 minutes to read the definition and 3 minutes to try to set up the formulas by yourself. You don't need to finish the calculation, just try to set up the formulas by yourself. Don't worry if you made any mistake, we'll come back together to think about it. Okay, so together 5 minutes, 5 minutes, read it and think about it. Okay, great. Thank you, Elizabeth, for putting this question out. I missed this part, right? Thank you very much, Elizabeth. So by what factor is the time increasing at this time? Do you guys remember factor? Factor is just how many times you multiply the original value. Okay, let me write this down. This is not a rigorous math words, but it's just my intuitive explanation about it. You multiply the original value. How many times you multiply the original value? So in this case, originally we have 10,000. Then we multiply with 2 to the 5, which is 32. So the factor, the time, by what factor is the time increasing at this time? So the factor is just 32. Okay, just this value. So if it is decreasing, it's multiplying number smaller than 1. That is okay. Still the same description applies. You're still multiplying with a number. That number becomes your factor. We will see in the following example when we multiply a small number. So that number will also become our factor here, okay? Elizabeth, did I answer your question? Great, thank you for asking. I really appreciate the students who ask me questions. Okay, so now read your half-life issue and example 2, please. Feel free to ask me any question. Okay, so let's come back together. So whenever there is an increasing problem, we always have a decreasing problem. So when the quantity is decreasing after time t, an exponentially decaying quantity with a half-life of t half decrease in size by a factor this. Do you guys notice there is a similar pattern here with the previous question? Previously, we are multiplying with 2 to the power. However, this time we're multiplying with 1/2 to the same power. If you multiply with 2, you are getting bigger and bigger because 2 is bigger than 1, right? If you are multiplying with 1/2, you're getting smaller and smaller because 1/2 is just smaller than 1. If you multiply a number smaller than 1, you're getting shrinking, right? So this is the idea. Then, exactly in the same way we calculate the new value. The only difference is that we are multiplying with a number smaller than 1. Here is 1/2. So as you can see, as t gets bigger and bigger, this power getting bigger and bigger. The 1/2 is to this bigger power is getting smaller and smaller. Okay, so that's all the tricks we need. Anyone have any question about this understanding of this concept? Okay, so let's do some radioactive experiment. A sample of cranium 457, initial mass 500 grams. If the element has a half-life of 5 years, how much of the sample will remain in 20 years? By what factor is the sample decaying at this time? We have the initial mass so much. We also have a half-life, 5 years. So how much time? Time is giving us t equal to 20 years. So we got all the information we needed to solve this question. So new value equal to the initial value, which is 500 times 1/2 is still 1/2, just copy from there. T half equals to 5 years. T equal to 20 years. So we just finished the calculation. This is 1/2 to the 4. Okay, so 1/2 to the 4, how much is it? Is 2 to the 1 to the 2 over 2 to the 4. If you calculate, you will see 1 over 16 here. Okay, so 500 times 1 over 16. How much is this? Let me put in my calculator. How much is this? Oh, kiddies, thank you so much. So we only have 31.25 grams, don't forget the units, left. Okay, that's how much we have, 31.25 grams. So by what factor is the sample decreasing? Remember what we just discussed, factor, just how many times you multiply the original value. So in this case, we multiply the original value with 1 over 16. So the factor is just 1 over 16. That's it. You just copy, paste. Okay. Does anyone has any question on this one? Okay, so that means every calculation is easy. Okay, so on our first page of our lecture notes, we learned how to use halftime to calculate the new value. On the second page, we want to know what is the approximate doubling time or exact doubling time. On the previous page, doubling time is given. Now we need to calculate. Okay, so we have two formulas. The first one is approximate, so it's roughly correct, only roughly correct. Look at it, the formula is very simple, easy to use. So when you don't not need very high precision, you use this simple formula. However, this simple formula is tilde tilde. It's only an approximation, so it's not 100% right. So if you want to be very accurate, you need to use this formula. This formula is strict equal to, so it is very accurate, but the formula is kind of big and it use log, so it has, you need to do more calculation than just this simple formula. Okay, so again, I will give you 2 minutes to read, okay, 3 minutes since we have two parts. 3 minutes to read the two formulas and another 3 minutes to try to work out the example 3. Again, you don't need to rush to plug into everything into your calculator. So I think your number one goal is try to set up the formula. Don't worry if you make any mistakes. We will come back together and discuss it. Okay, so together you have 6 minutes to read what's on this page. 6 minutes. Okay, great. Let's come back together. So first, I noticed that Queen asked a question. What does it mean by a fractional growth rate of the value of R? Okay, so I will explain when we reach here. Okay. So the first formula is kind of simple. If the quantity is growing exponentially at a rate p% per time period, the doubling time is approximate 70 over p. So if here is 50, is 10% is 70 over 10. If here is 8% is 70 over 8. The approximation works best for small growth rates and breaks down for growth rate over about 15. So 15 is a threshold. If you see a value which is greater or equal to 15, that will be too big. So please do not use this formula if your growth rate is more than or equal to 15. Second, for an exponential growing quantity with a fraction growth rate R, the doubling time is this. So we do not know what exactly R is, but let's look down to find some clue here. For example, if the fractional growth is 0.05 per month, the doubling line is, will also be measured in months. So this line did not tell us the solution answer directly, but it gives us a good hint. What is the fractional growth rate 0.05 per month? It means that the rate, which is, look at here, is just 5% per month. Okay, just 5% per month. Similar with the P here. Queen, did I answer your question?
Yes, thank you.
Thank you for asking. Okay, this formula looks messy, but do not be afraid of it. Remember that all we need to do is find the information in the stated question. Once you find all the information you need, just plug it into the formula. And this is actually easier because in the formula, we only need to find R. That's the only part we need to find. So it should be easy. Small town, this time is in Montana, has the initial population 100 people. Really, this is really rural Montana. The town is growing at a rate 5% per year, answering the following question about the small town. What is the approximate and exactly doubling time of small town? So in other words, we just need to use both formulas to find the approximate time and exact time. So the growing rate is 5%, so which is 5 here. So T double approximately equal to 70 over P. Remember, P is this integer, okay, without percent, P%. So here is 5%, so P is only this integer. So do not copy 5% here, just copy 5 here, please, which is 14. 14 years. YRS represent years. So this is approximate time. Exact time This is a proc. Exact T double log 10 to log, I'm just copying the formula here. 10, 1 plus R is 5%, okay? This time you are calculating just as it is. Just as it is, 5%. So, can anyone help me do the calculation on the calculator? Anyone can help me? Thank you, Kiddist. So the exact time is 14 years, 0.2. Okay, so we just take 2 decimal. 0.21, okay, 2 decimal. The 6 here rounded to this 1 here. So you see the approximate time is very close to the exact time. 14 years with 14.21 years. They're very close. Does anyone has any question about this part A? Great. So we figure out this part A already. Now our job is trying to use the result of part A to figure out what is the approximate time and the exact time in 20 years. So we're just repeating what we have done on the first page. We know this doubling time already, so we just want to figure out how many people are there in 20 years. First, let's approximately, I just write approx in short. 14 years, right? 14 years is here. So initial value times 2 to the t over 14. Initial value is 100 times 2 times t is 20. Doubling time is 14. Is just this. So it's approximately 100 times 2 times 1.4. Okay, I'm super lazy. I know we have smart people in our class, diligent people in our class can help me figure out this calculation on their calculator. Please do that. My job is just listed on the paper, list all the formulas on paper. So exact time is 100 times 2 times 20, 14.21, which is equal to, do me a favor, plug this into a calculator. Oh, great, I see Queen. So Queen, I see your result, 269.18. So this is for the approximate value or the exact value. Hello, Queen?
That is the approximate.
Thank you. Would you please also help me with the exact value?
Yeah, give me 1 second.
Okay, great, Queen, thank you very much. So if we are using the exact value, it will be 265.27. We need to round it to the integer. Does anybody know why we'll need to round it to the nearest integer? Anyone?
Because you have 27 of a person.
Very good. We never have a 0.18 person. I mean, we never have a 0.18 living person. If a person is dead, maybe you can, just a terrible joke, maybe you can cut the person in half or a quarter. However, we never have a living person which you only have like a 0.18. Okay, so we need to round it. Part C is very easy. We just find the factor. So we just see what this part is and what this part is. So Queen, since you did this calculation already, can you please tell me? Oh, I actually don't need your help. I can just read the answer by myself because we have 100. So 100, which is 1, kind of similar with 1. If you time anything, it does not change anything, just make it bigger proportionally. So the approximate, you see 100 turn out 269. So it is multiplying with 2.69 here. Exact is multiplying with this part, and we know this part must be 2.65 because that's how 100 multiplied with 2.65 give you 265. Okay, that's it for this question. So just read from the previous answer and do some calculation like this. Does anyone has any question on this part about this factor stuff? Okay. So we did something related with growth. Now we also need to do something with decreasing. Not everything is growing. Some rare species is also decreasing. We are going to talk about Chinese antelope. However, as always, before we do any question on any topic, I'd like to show you guys a video so that you can have a more vivid idea of what we are talking about. Okay, so do you guys see my screen?
Yes.
Great. So we are going to watch 2 minutes video.
Let others know you're unavailable by pausing notifications in Slack. Turn on.
我们去巡护的时候，这10公里左右我们就见了19只熊，就是棕熊。它是有母熊带着小熊的，也有这个成年熊一起搭伴的。其实这个很少在其他地方能见到，因为藏羚羊产崽季节，藏羚羊它全部都集结到这个产崽地，所以说对它的天敌来说呢，就是饕餮盛宴。它就是把这个小藏羚羊，先是用爪子抓起来，然后飞到天上，再把这个小羊给扔到地上，就是把它摔死。一般都是它带到自己的窝里去，因为它也这个呼呼就它也有自己的这个窝里面有小鸟。 藏羚羊，它的这种生命力的顽强，作为一个旗舰物种，作为一个这个基础物种，支撑起咱们的这种青藏高原的这个生态平衡，也是值得我们去守护、保护。值得支撑，因为像是作为一个它的这个基础也是值得我们支撑起咱们的这种青藏高原的这个。
Okay, let me ask you guys a question. Do you guys notice what is the population in the video? Okay. Hello, do you guys notice what is the population number in the video? Do you guys pay attention? Okay, let me check the video again. So I think somewhere near the end, it explicitly says the population. Okay. So I found it. You guys see the number here? Look at my screen, please.
Yeah.
Okay, so 300 sounds. And in our question, it was saying that it only has 30 sounds, so that's just a made up number, not real.
Yeah.
So let's go to the question. Okay, before we do the question, I think I can give you like again 5 minutes to read the formulas and the example 4, okay? Together, formulas and example 4, 5 minutes. Okay, 5 minutes is over. Okay, this time everything is reversed. We're learning the exact formula first. We're learning approximate formula later. But the idea is almost identical. We want to see how fast the calculation, how fast is it decaying, or how much time do we need to be half of the original quantity. Compare those formulas. What do you notice? First, compare. This is for doubling, this is for halving. So when you compare this with this, you find it is exactly the same formula for approximate formula, exactly the same. And exactly the same requirement, cannot change over 15% per year. However, when you compare with doubling time with half time here, what do you notice? We have a minus sign here. Yeah, Queen, it seems that you want to say something.
I was just gonna say I noticed the negative sign as well.
Very good, thank you. So that's the only difference. Here is just everything is positive. Here you have a negative. Okay, so everything else is the same. Let's see how we can apply the formulas in the following calculation. Okay, first of all, this statement is wrong. The Chinese antelope is not decreasing. Protection measures work and its population is rebounding, and it's rebounding to 300,000, so we do not worry about it. Okay, assume everything said here is still right. Let's do the calculation. It's decreasing at a rate 80% per year. Calculate both approximate and exact half-time for the Chinese antelope. So approximate time is easy. Still, T half 70 over P. P is 8. P is 8, okay? So exact time it is negative log 10 to log 10 1 plus 8%. Now you are using the decimal as it is. That's it. Okay, somebody help me to do the calculation. Okay, thank you. So as the approximate time is 70 over 8. I see somebody typing the chat session saying 9. So Elizabeth, so when you type 9, so what is the exact number you're typing? I know you're rounding. 70 over 8 is not exactly 9. So what is the number you on your calculator? Thank you. Thank you, Kittyist. Thank you, Elizabeth. So it's 8.75. Since we are calculating time, this in terms of years. So we can have 0.75 years, no problem. We cannot have 0.5 person. Okay, so how about this exact time? Elizabeth, Kittyist, did you figure out what's his number here? Okay. So here's a tricky thing. Oh, I see where I made a mistake. So when we look at this formula, the decay rate is denoted as negative. So we are not adding 80%, we are minusing 80%. I apologize for the mistake. That's why some of you get a negative number. So time can never be negative before we invented the time machine. So can you guys do it again? Do the calculation again, 1 minus 80% to see what you get. While you guys are working on this, I will set up the formulas for the part B. So I see Frank's answer, but you still get a negative answer. Would you please check your calculation again? So when you have negative, this over this, you should get something positive here, okay? So please check your calculation again. Should get something positive here. So in the year 2010, population was 30,000. The author of the question made a mistake. It should be an additional 0. So both approximate and exact have calculation above to predict the population in 2025. So we have 15 years from 2010 to 25. Just use what we did here, the formula here. Okay, we just use the formula on the first page. So initial value 30,000 times 1/2 T over T half. T is 15. T half is 8.75. I'm just setting up the formulas and leave you guys to plug into the calculation by yourself. Exact. $15 still the time. And we need some exact time. I see Frank. I think Frank's answer is correct. So the exact time is 8.31 years. So we put 8.31 here. Okay. So that's the exact T half. Okay, now it's your turn to help me to do the calculation. Okay, great. Thank you, Queen. So exact approximate population is 9142. Exact population is 8,085. That's it. So also, Queen, since you did this calculation, would you please also tell me the factor here and here? Halsey asked us a factor. So again, we just need to look at the number here and here. What are they? Okay, great. So I see you type 0.3048. That's for exact or approximate.
That one's for approximate.
Very good, thank you.
And then this one is for exact.
Okay, we're just finding the number again in our calculation. Very good. That's it. Exact timing, 6:15 p.m. Okay, does anyone have any question on this? the calculation is very similar with the previous one. Okay, we're just repeating it. Great timing. Do not go before I take attendance. Okay, do not go, do not go. Let me take attendance. Okay, I have an issue to tell you guys. So one last issue before you leave. So I just took the attendance, but I noticed that many students come in the class late. So starting from next class, I take the attendance at the beginning of the class, okay? Just let you know, starting from the next class, I'll take the attendance at the beginning. Okay, great. So stay here if you have any question. Otherwise, feel free to go and have a great weekend. Bye-bye.
Thank you.
Thank you. Have a good weekend.
Yeah, I actually had a question about the project for 4C.
Yes. So you have
So do
a
I.
general question, or you have a calculation about running a detailed calculation question?
I think it's more calculation because I sometimes get mixed up on which equation you're supposed to use, if you know what I mean.
Yes. Would you please share your screen?
Oh, unfortunately, I only have on paper. I don't have it on the computer.
Okay. So,
Yeah.
okay, try to state your question verbally so that I'm trying to understand.
Yeah, that's okay. Give me one moment because I need to pull it up.
Okay.
I just didn't know if I did the calculation right or not, but I was just wondering for example, on letter B and C for number 1, do you use the equation that has like the initial amount times the like the percent over the 12 and the 1 minus in parentheses 1 plus whatever?
First, I apologize. I literally cannot get what exactly you're asking. Would you please share your screen? Or you have any other measures so that I can know what exactly you're talking about?
I'm just trying to think how I can't think of it. Maybe I can pull up the equation quickly, and then by then I can share my screen.
Okay, so
I was just confused which equation, so yeah. Give me one
so
moment,
you have a question about the project 4C, right?
Yeah, for project 4C.
Okay, let me open 4C on my screen and share
Okay.
with you. So, do you know how to control my screen?
Not really, not gonna lie.
Isn't there a
Okay.
share screen setting at the bottom?
Yes, you can literally control my screen to exactly point out what question you have.
I had a question on 1B and C. That was my main question.
1B and C.
Yeah.
Okay, here they are.
Yeah. So I was just wondering, 'cause I don't know if I used the equation right. Which equation would you use to find B and C?
Okay, so I think we okay, let me find the lecture notes. One of our this is 4C project, so the corresponding to the section 4C. So let's go to the lecture notes for 4C. 4C is here. 4C written notes is here. I prefer written notes because that's my written. So you are just using this formula. Okay, I'm sorry. I'm sorry. So since you are buying a house, right? Are you buying a house?
I mean, for the
Sure.
project, sure.
What does the question ask you to do?
To figure out the monthly payments.
Yes, for a house, right?
Right.
Yeah, it says we're buying a home for $22,000 with the 20% down with an interest rate of 6.5%.
Okay, so let me think about. Okay, so I apologize. I think this does not have the formula we need. So
Yeah,
maybe in
I
section,
thought it
yes.
was. I thought it was under the formula that had like the negative exponent, where you're like supposed to have the exponent of like negative 12 times whatever. Isn't that supposed to be the equation? Yeah, that one.
Yeah.
That's what I use.
Okay, so let me see. Okay.
Hmm.
Okay, I see. So you should use this formula. Yeah.
Okay, so that's the correct formula to use for letter B and C, correct?
Do
I'm
we use
sorry, I
that
did-
same formula? Throughout the project, do we use that same formula?
It all depends on the question. So if the question is calculating something about loan or mortgage, you use this formula.
Okay.
I didn't realize. So look, we have the in the lecture notes 4D, we have exact questions on how we calculate a mortgage. Apologize, you need to reverse it to see what's written down here. Yeah, so you see, a very exactly the same question, not exactly, very similar question is on the third page of 4D. And then we did it in class. Okay, does anyone has any question? Hello, are you there?
Still here.
Yeah, that helps. Thank you.
Okay, great. So thank you for asking. Anybody else has any question?
I'm just seeing if there's anything else.
Okay, so Sujibala, is anything I can help you right now?
It doesn't look like it. Thanks. Yeah, that was
Okay.
that was something I didn't get.
Okay, great. So thank you for asking.